Okay, so yeah, about a month ago I mentioned in the speakers channel that I would had a talk, and it was going to be strategies for dealing with legacy code, and that's because I'd been dealing with legacy code quite a bit for the last 12 months, and I thought I could gather my thoughts together and create a talk out of my thoughts, and I was wrong. So actually this is going to be a bit of a story about a specific code base that I've been working on, where it was 12 months ago, what I've done with it, and kind of where it is now. And it is a legacy code base. So I'm going to set the scene a little bit. So there's this thing, there's the monolith. Back in 2017, March 2017, I was contacted, or we were contacted at Itty Bitty Apps for me to come in to a bank. I'm not going to tell you which bank, but you can probably guess which one. And to help them build a new banking app to replace their current one. Or it kind of was. We actually were going to repurpose an existing app that they had and make that the new banking app. So this existing app, the Codebase, it's all Objective-C. We had about 2,500 lines of Objective-C, or files, sorry, about 193,000 lines, about 5,000 lines of Objective-C++, about 86,000 lines of headers, and 1,500 lines of Swift. Someone had snuck that in somehow.
How does Objective-C++ fit in?
When you want to interface with GSOAP, GSOAP is a C++ library.
You don't want it.
No, you don't. Anyway, so it's old code. Some of the code goes back to 2012, 2013. It has had many hands in the code. I did a little git log check on the codebase for all the authors. And yeah, up to that point in March of 2017, there'd been about 60 devs, plus or minus a couple and a few bots.
Is that the real diversity?
Yeah, it is, and that's me guessing, actually. I only recognized maybe half of the female names, and the others were from areas unknown, but maybe they might have been female names, so I counted them as female. They could be boys. Yeah, so not great for diversity. Funnily, Chris Venter, now you'll know where this bank is coming to talk about diversity on Thursday. Anyway, that's that then. Now, a year on, about 110 developers have committed to the codebase. So that's 50 more in 1 year. So that's interesting. Not all necessarily developers, a lot of testers as well, automation testers. Anyway, so this codebase is very had a project-driven development model. Money is budgeted, devs get to work, they work hard, they hit the date, and then they wave goodbye. So that's probably why you had 60 devs. Though some of these projects were pretty long, like multi-year projects, but it was definitely a bit lumpy, let's say, the codebase. Anyway, the codebase is made up of an application, a watch extension, Todayview extension. It had 11 networking and domain foundation-oriented modules, 21 UI libraries or UI support modules, seven core functional area modules for banking, superannuation, insurance, registration, stuff like that. They weren't the pods, they weren't the third-party libraries. These are the internally developed things. If I added the pods in there, it'd add a bunch more. So about 38 of these modules, they were originally CocoaPods. If you were here a month ago, you might have heard me talk about lots of CocoaPods and as a question to one of the Zero guys. Anyway, previously the app had been through a sort of, so all of these, they had lots of CocoaPods that were internally managed and it created a nightmare. So someone had the smart idea of bringing it all together into a mono repo. And so it basically been through a process of depodding, but no one had bothered to reorganize the files. So they're just in directories in the Codebase. Anyway, so as I said, in directories. The file system was pretty much a mess. Lots of inconsistencies in folder layout, and particularly inside the modules. Like, it's every pod seemed to have a different way of laying out its file structure. Third-party libraries that I hadn't mentioned, the number of, a lot of them were out of date, unmaintained. There was no obvious project architecture in the course grain. Like, areas of the app, depending on which projects, had adopted certain design patterns and certain architectures within their areas, but not globally across the entire application. And nearly all the code was Objective-C, and the developers, a lot of them felt like they were being left behind by Swift, because this is in 2017, right? So Swift 3 was already out. And someone had snuck in like 30 files of Swift somehow. I wasn't blessed. Just adding to the build time and the size of the app. Anyway, so problems. There were very coupled code, a lot of header dependencies, a lot of hidden header dependencies. Thanks, prefix files. Yeah, don't ever use a prefix header in your Codebase. Not that you should be really using Objective-C much now, but if you are, unless you're doing C++, don't use PCH files. They are the devil. Developers could import anything from anywhere. Now, this is a bit of a problem with CocoaHeads, not CocoaHeads, CocoaPods. CocoaPods, yeah. I hadn't really grokked to this until recently. It was mentioned in the release notes, I think, for CocoaPods 1.5, where they introduced Swift static libraries, where they had to rework the way that they did the header includes for CocoaPods, or the include paths. But basically, I think, if I'm reading what they said right, when you're using CocoaPods, essentially all headers are public, well, at least the ones you make public in your pod spec. And you can include any other pod's headers in your particular header. So that may have been a problem beforehand with the CocoaPods, the internal CocoaPods that this bank was using, but it definitely became a problem more so when all the pods were brought together and everyone could just basically hash import this header because it's got something I want. Yeah, and the other problem was there was a long build and test cycle on the app because 2,500 files and a bunch of C++ that takes a minute to compile. You've got a big long build, and so if you change the prefix header or anything included by the prefix header, you have to build everything again. And so the test cycle time was pretty slow. People hated writing tests. And yeah, it was not a good place. The other major problem I had was singletons. Singletons everywhere. Which brings me to a rant.
How long have you had that slide?
I actually went to Meme Generator yesterday and made that, but I'm sure it was probably there, yeah, anyway. Okay, the rant, all right. Singletons. I'm going to read what Wikipedia says. The singleton pattern is a design pattern that restricts the instantiation of a class to one object. This is useful when exactly one object is needed to coordinate actions across the system. Oops. Okay, so the key words here are restricts the instantiation. This is kind of a parenthetical afterwards. It's like, oh yeah, and you also have to be able to access that instance. So it's like, how do we do that? Oh, well, it's global, so it's convenient. But the pattern, it's not the primary intent of the singleton. The primary intent of the singleton is that it is a single object. You cannot create more, or you shouldn't create more. So, more for Wikipedia. So singletons, considered by many, including myself, to be an anti-pattern in that it is frequently used in scenarios where it is not beneficial. It introduces unnecessary restrictions in situations where the sole instance of a class is not actually required, and it introduces global state into your application. So singletons were designed to avoid the situation where you don't want to create more than one instance of a class. Okay, the intent of the pattern is not necessarily to create a convenient way to get at something global. All right? Because we all know globals are bad, right? Right? Shared mutable state is the devil. Don't do it. Okay? And if you don't know why globals and shared mutable state are bad, that's okay. But please read up on it. I'm not going to explain why. Okay, so what is an actual use case for a singleton? Well, a physical serial port might be one. I'm not talking about like modern Unix systems which have serial devices or other devices modeled as files where you can use file locking to avoid accessing them simultaneously. But maybe on an older type of computer, a DOS one maybe, or System 7 Macintosh. Maybe it uses memory mapped I/O, right? And so anything in an unprotected memory, like a System 7 Mac or a DOS PC, can write to any memory anywhere. So in a system, you might want to write a wrapper around that memory, which you can only allocate once. So you can coordinate access to it through that thing so that you don't write random bytes in random order out of your serial port from different parts of your application. All right. So you've got to remember that these design patterns were written in the 90s, right? So this is the sort of problem they were trying to solve. Anyway. So the other things that might actually be singletons, but aren't modeled as singletons. So on your iOS device, your modern Unix-based mobile phone, you have a GPS. There's only one GPS, as far as I know. Renault might know better. And it's managed by a daemon. And that daemon is a single instance, obviously, but it's managing the device. The way you connect to it is through Core Location's CL Location Manager. But you can instantiate as many of those as you like. And you can access it in a variety of different ways. But it's ultimately providing you access to some single resource. But it's not modeled as a single resource. So you don't have to either. Anyway, so Singleton Alternatives, obviously, sometimes you can't avoid them, but even if you do have them, you can at least use dependency injection to get them into your code. So you get better testability, and you get the ability to refactor easier. Just because the OS provides default singletons, you don't need to use them directly either. You can inject those. And just because iOS provides a default notification center instance for the system notifications, it doesn't mean you have to use that to broadcast your own notifications. I don't know if you've ever noticed, but you can instantiate Notification Center yourself. And that means that you can do things like internally within your own framework or your own application, use a private instance or your own instance of Notification Center to broadcast your events if you're going to use notifications for multicast broadcast or an event bus or something. And they don't mix up with the system notifications. It means you don't get a performance penalty, not that that's significant these days, but yeah, it gives you other options. So think about that when you're wanting to use things like, NS Notification Center default and so on. All right, end of rant. So what are the solutions to my problems on my legacy codebase that I was dealing with? So I'd inherited this messy old codebase, loaded with singletons, and I needed some solutions to try and sort of rationalize things, make things better. The first thing I wanted to do was at least have some sort of target architecture. So from this diagram, hopefully you can see it, it's a pretty simple idea. It's to layer your application in architectural layers, right? So that you have an idea of where to stick things. In this case, we have a foundational layer, we have core networking, core domain model, some domain-specific network clients, UIKit, an extension support library, application support library, a legacy library, we'll talk about that later, identity support library, and near the bottom we have banking, superannuation, customer support, insurance and investments, and we have an application, a watch extension, and a Today View extension, which are the things that the OS actually runs, right? And the imports all go this way. They can never go that way, and they can't go that way or that way. So obviously core networking can import foundation. It can't import the domain model. But the domain-specific network clients can import core networking and foundation and the core domain model and use them together. But they can't talk to the UI kit. And I'm not talking about iOS's UI kit, I'm talking about like your own private widget library. And so on and so forth down the layers. So this is obviously more important in a big project, but in a smaller app, you might have a smaller scale version of this. It provides an encapsulation model, right? So it's encapsulating all of the stuff related to the core domain model in that model. And so if I change anything in there, like I could have that all be Objective-C, and then one day I rewrite it all in Swift. And as long as I'm exposing the same types using Swift to Objective-C bridging, everything should be fine. I don't care, like nothing outside of it should care that I refactored the entire contents of it. It also, by having that encapsulation model, you're effectively limiting the blast radius of changes. So if you go in and you change some aspect of things in there, if it's not public, it shouldn't matter. I mean, obviously the behavior changes, it might matter, but if you are refactoring without changing the behavior, it shouldn't matter. It also means that if someone does something really dumb, or something suboptimal, as Blast might say, the impact, especially if it's not public, if it's not a public symbol, isn't so great. It doesn't leak out into the other areas of your application. Like people don't see it. They're like, oh, that looks nice and interesting category on string, I'll just use that. All right. The other thing that was a major problem with the project was the file structure. So just progressively reorganizing it, doing it, creating, it's a pretty, DexSet's really bad at some things. But anyway, it's the outline of the basic structure of the project now, not then. Configuration documentation, each application level target has its own directory. Inside that has configurations, tests, sources, resources, and so on for the frameworks. And then you've got pods and scripts and tools and things. And so, and that's consistent, making that consistent across your entire project. So the reason, some people might go, why do you care about that sort of thing? Why do you care about why the file system looks a certain way? Well, it's because architecture isn't just about picking MVVM or MVC or MVP, right? Architecture extends to your entire project. It's how you structure your project on disk even. It's how a developer finds their way around, figures out where to put things. You want this to be as consistent and obvious as possible. And maybe enforcement is a good idea. So in several projects now, including this one, we actually enforce this structure. So if you deviate as a developer, you create a new directory, for example. If you create a subdirectory in sources, the build breaks. You can't do that. You're not allowed. Yeah, and so you put in a resource file in the sources directory. It just breaks the build. Obviously that's, you know, whatever standards as a developer or as a team lead you want to set, you can do that. I'm not necessarily saying my way is the only way, but it is a good idea if you want to have a standard to have some sort of measure of enforcement. The other thing we did was remove a lot of the third-party legacy libraries. We either upgraded them to the latest source compatible version if we could. Some of them we just effectively adopted into the project. There was just little point in maintaining them as third-party dependencies because they might have been used in one place for one thing. Let's have 100,000 lines of code to display a graph once. So, you know, stuff like that. And in the process, we might have renamed a few things, like particularly around small libraries like Facebook's KVOController got imported and renamed because it was used once in one view controller. The other thing, of course, we did, which is alluded to in the architecture diagram, was we introduced a lot of frameworks. We started building frameworks. The code in these frameworks obviously could be Swift and Objective-C, which let the developers finally start coding in Swift. And we started moving what we thought was clean enough code into some of these frameworks. But that was really quite slow. And part of the work also was trying to redevelop some of the base foundational bits and pieces to replace the legacy systems in Swift to give it a bit of a nicer, cleaner, shinier look and feel. But as I said, moving the code that we considered clean enough was quite an arduous task because you had to do a lot of things like nullability auditing and enforcement. Yeah, so fortunately, Swift gives you a lot of, well, Swift and Objective-C library, Cocoa generally, they give you a whole bunch of tools for dealing with what we might call legacy code, legacy Objective-C code, and then bringing that into Swift code. So I assume, how many of you are familiar with these things? How many of you are not? Okay. So these are macros mainly on the C, Objective-C side of things, right? So init assume non-nil begin and end helps you avoid having to annotate everything in your header files as nullable or non-nullable. Sort of a blank slate. You can just say bang at the top of your header, bottom of your header, and there's a few built-in special cases that it opts out of. Things like errors and stuff are always nil or nullable. And that's great because it makes your APIs easier to consume, or your existing APIs easier to consume in Swift code because you're not dealing with optionals and what have you all the time. But it's kind of shit if it's actually not the case, i.e. your code can accept nils or if it, stuff like that. So really, if you're going to audit or say that your code is non-null by default, you should really enforce that. So within the code, all the parameters that are expected to be non-nil, you should have a parameter assert stating that. And I would encourage you not to disable asserts in release mode. But anyway. The other nice thing you can do, obviously, is rename things. So if you've got some horrible prefix on your code, for example, and you don't want that in your Swift, you can use Swift name for your classes to rename the class, remove the prefix. You can use Swift name on properties and functions and so on to give them more Swifty style names. Drop lots of the withs and fors and things. We'll move them around in the method signature. If you want to tweak it a bit. And of course, on the other way around, if you want to expose things to your Objective-C code from your Swift code, using the add Objective-C annotation is required now, unless you've tweaked your build settings. And that can take parameters to give you a more Objective-C name for your Swift property or function. And then, of course, if you really want to mark stuff in your legacy Objective-C APIs or whatever that shouldn't be used at all in Swift, you can mark it in as unavailable for Swift. You can use it as unavailable to mark things that are not available in Objective-C as well. And you can, of course, use it as deprecated to generate lots of warnings. And it's refined for Swift lets you sort of rename a method in a way that lets you wrap it in a Swift version in your Swift code. And you should always be using designated initializer macro to mark your designated initializers on your Objective-C code so Swift makes intelligent decisions. The other thing, as I said in the beginning, was a big problem in the Codebase is this massive build and test cycle. And the great benefit of using frameworks is that you can move the tests into the framework. So for all of the code that belongs to a particular framework, I was lifting it over using git move, moving it around, doing lots of basic file manipulation and project manipulation, and moved all the unit tests in there as well. Set up a test target for that particular framework, run those tests in that framework. That was a fun thing. It found lots of bugs, lots of interdependencies and flaky tests because mutable state between tests. That's cool. Yeah, but anyway, that did, however, help greatly in the testing of this process of reorganizing all the codebase into a bunch of different frameworks because it let me run the unit tests for that specific framework to see whether I'd broken anything. Yeah, so just basically having tests in your frameworks helps you test your software better and faster. On the Objective-C side of things, you really want to minimize the amount of public API you put in your umbrella header. So if you've got a framework which is primarily Objective-C, there's probably a lot of code in there that actually isn't public. Like it's just, you've got a view controller, it uses a view or something else, data source or some other helper controller. And that's not really public API. And so the header for that thing doesn't need to be in the umbrella header of your framework. So you got to be picky and choosy about like what actually gets exposed into your in the umbrella header. And sometimes that means you might need to chop up header files and things to limit the visibility of certain types. And really, ultimately, the umbrella header on a Objective-C framework gives you access control for Objective-C. It doesn't actually truly make the symbols private, but at least you can't see them by default. So one of the frameworks in that architecture diagram that I showed before was called Legacy. And this is something we did relatively early on, after we realized basically that trying to audit code and move it around was going to become a massive piece of work. And so it was basically a halfway house for all the legacy code. It enabled the sharing, so there was a lot of different modules that used certain things, and we want to break those apart. But if they're using they're using a shared symbol or shared type, we need a place to put them for it to be shared. So we created this legacy framework, which kind of became a dumping ground of everything that was shared by all of the other legacy code. So this really helped us accelerate the creation of the other frameworks. I'm nearly done on this particular mission, and I don't think it would be possible for one individual to do all of that without something like this. It would just be too much work. And it kind of gave us a blessed location to put the shared code that hadn't been audited, that might one day, if it doesn't get replaced by something else at some point, it might get blessed as being, oh, this actual code, this we want to keep, we'll put that in Foundation or UIKit or the domain library or something like that. It's primarily Objective-C and primarily not wanting to be exported into other things. So one thing I have contemplated but haven't done yet is actually make importing of this library into Swift a lint error, so you can't actually import it. I think the boat might have sailed on that. People are already using it. But anyway. So APIs, I don't wish this particular mission on anyone else, but if you ever had to or wanted to break up your app into frameworks, there are a number of APIs in Cocoa that might cause you problems. And they kind of have a bit of a theme, and those are really around implicit bundle references. So APIs like UI image, image named, and image literals, they only search the main bundle by default. So if you're moving your assets into asset catalogs within frameworks, which works fine, you are going to have problems because those APIs return nil, and if you then feed that into Swift, it's not expecting it, it's going to crash, or you're just going to have missing icons and what have you in your app silently. Like normal Objective-C code doesn't warn you about this sort of situation, just doesn't work. What you really should be using instead is this other API, which has got more parameters, image named and bundle compatible with trait collection. and that obviously gives you the option of passing in a bundle. And what I tended to do is actually just create wrappers around all of the assets. So I create a category on UI image and for all the assets that are in a particular framework, and then replace all of the stringy access to those APIs with these category methods, which were strongly typed and crashed if they didn't find the image, because that's a program error. Like if an image doesn't exist in an asset catalog and you expect it to, you should crash. You shouldn't just blithely carry on with a nil pointer to UI image. So just generally avoid stringy APIs if you're working with frameworks. So the other places where you have implicit bundle references are things like init with libname bundle, UI_libname with bundle, and NS localized string. So often people will just pass nil in here for bundle and in here because they just expect it to search the main bundle, and you don't want that. And the default macro, at least on Objective-C, doesn't mention the bundle for localized strings, but there is an alternative you can use, and obviously in Swift, it's got default parameters and stuff. And otherwise you're constantly searching the main bundle where your resources probably aren't. A better approach is to use the class name. In fact, this is the default behavior internally within UIViewController. When you pass nil for the nib name and nil for the bundle, it searches the main bundle, but you pass nil for the nib name, it searches for a nib that is the same as your class name. So you can mimic that behavior by just using NS string for class and NS bundle for class. But in that case, search the framework bundle. And the same goes for UINib. The other place where things fall down is explicit bundle references. So lots of people like using main bundle in their code for some reason. Sometimes they pass it into the functions like those ones. Whoops, where am I going? Wrong direction. Loading nibs using the bundle, which is an ancient and avoidable way of loading nibs, but people do it. It's off the bundle, so you can obviously replace the bundle that it uses. What we tended to do was create a helper which created a static method on bundle to locate the particular framework, and that helped a lot. So some things did help in this process. As I previously mentioned, tests helped a lot. Fortunately for me, the project had a wealth of unit and UI tests. Not all of them great, but they were there. So these tests made me much more comfortable in moving the code around and refactoring. The UI tests also helped a lot. They caught a lot of errors and issues that the unit test didn't catch, particularly around the resource loading and nib loading and things like that. And without these tests, my job would have been much more scary, and I would have had much less confidence that I could actually pull it off. All right. Now, when you're moving code around a lot, what you find is you end up in sort of cyclic dependency problems, where you have A needs B, B needs C, C needs A, stuff like that. Or even just simple things like I'm moving a whole bunch of code out of the main code, main project target and into a framework, but it's depending on code that I haven't moved yet. And this is where dependency injection and replacing some of these singletons, because often these dependencies were just singleton dependencies, like they're essentially saying, oh, I need the account broker to do something, and I'm just going to access its shared instance over here in some random view controller. And so I came up with a little bit of a strategy for fixing some of this in some places. It was a bit inconsistent across the Codebase, as I mentioned, so I had to kind of adjust my pattern as I encountered different ways of doing things. But the basic principle is this way. So you might have, we've got the application target and it has the account broker in it. Admittedly, this thing probably belongs somewhere else, but at the moment that's where it lives. The Superannuation framework, which is newly created, for example, it's not actually the case in this particular framework, but we're using that. There's a view controller that wants an account broker. Maybe it wants to be initialized with it. Maybe it was originally just using it as a singleton, because it's a singleton. Doesn't need to be, but it is. And so the challenge was, okay, how do we fix this? How do I make it so Superannuation framework, they can't import the application because it's on the layer below, and shouldn't import the application. You can't. It needs to still use it. So the solution is create a protocol. That protocol has just the subset of functionality from the account broker that the superannuation system wants. And then because the superannuation system in a variety of places wants to use this as a singleton, and I want to change as little code as possible, I have to create another singleton, which hurts what I do. But this singleton is a bit different. It doesn't instantiate itself. It expects to be given an instance to vend. So it has a static method configured with superannuation, a super account broker, and that is of type super account broker protocol. So wherever the account broker existed in this module, I've just replaced it with a protocol, and I've created a vendor for that singleton where it's needed. So the idea being to isolate and encapsulate the behavior into that framework. The other thing is that I'm now expressing the behavior and needs of this framework in terms of something it owns. So it's in terms of this new protocol. And so as long as something conforms to that protocol and adopts the behavior that this expects, I'm free to refactor everything outside of this framework, as long as there's something that behaves like it used to, right? So this thing's no longer tied to how account broker over here is actually implemented, which is a key thing to sort of managing legacy dependencies. So the next step being to inject the account broker into the superannuation. So we create a class here which adopts that protocol and implements it in terms of the protocol expects. It doesn't actually matter that it's just basically forwarding it on at the moment to the old implementation. This could be changed at some point. And then, and the last thing is we configure a startup task. So this app has a mechanism by which it starts a whole bunch of startup processes on application to finish launching. And we create one of those, expose it publicly from this framework, and it expects to be passed one of these as a configuration parameter, as an initialization parameter. So during the very first bit of the app, near application to finish launching, we instantiate one of those, pass it to this guy, kick it off, put it in its queue, executes. So that sort of pattern and variations on this pattern helped a lot in isolating and decoupling the different bits and pieces from the different frameworks so that they weren't interested in parts of the system that they didn't really need to have access to. And good old David Wheeler, I love quoting him. It's like, all problems in computer science can be solved by another level of interaction. And that's essentially what we had before, so I just introduced another layer of interaction. But of course he also said, but that usually will create another problem. So, and he's very right. I've just added more complexity and more layers. Hopefully the good of the extraction and modularization of the Codebase outweighs the downside of the extra layers of indirection. So where do we end up? Well, we got more code in the end. After another 12 months of development, what we've ended up with is about 5,000 lines less Objective-C and 41,500 lines more of Swift. So there's still got a lot of, there's still a lot to do at this particular application. We've still got a lot of code to delete. There's still obviously a lot of legacy behavior. We were adding features, we weren't taking them away. And so that team has a lot to do. We do have a much more modular application. It's a little bit easier to just figure out where the hell you are in the Codebase. It's made up of a variety of frameworks. We can do some funky things like develop an entire replacement subsystem for one of the major functional areas beside the old one, and have it essentially toggled off in sort of a build feature. And we actually delete that framework before we ship it. So it's just weakly linked, so it doesn't cause a problem. But yeah, and frameworks let you do that sort of thing. So it has opened up a variety of other possibilities. Basically there's still lots of work to be done, but I'm pretty happy with where we've got to so far. Excellent success.
Are there any questions for Oliver? All right, I'll start at the front.
So, thanks for the talk, guys. That was great. You said you were forcing projects through scripts.
Yep.
How does that work in practice when you check things?
So we have a defined directory structure, and we have rules about what goes in those directories, what types of files. And so just wrote a bash script to check that. And we just put that as a build phase for every framework. It just self-checks basically to ensure that no one's chucked a PNG in the wrong place or whatever. And I also have a policy of no subdirectories, so we check for that. So yeah, there's just, everything's a flat file, just in one directory.
Thanks.
I have a question that's more about, I think, stakeholder management rather than pure software. Like all of the strategies and the problems that you have with the code and the strategies that you have to deal with them, I assume, like from someone who's non-technical, it means that you're going to spend a lot of time writing or deleting or moving around code, but not deliver quote-unquote actual value. How do you sell that to your stakeholder? Because I assume, I don't know which bank you're working with, but I assume that there's a lot of bureaucracy and inertia in decision making, right?
Yeah, I think that one, I think if I wasn't in the situation that I was in, it would have been a lot harder. And I think other people on the team would have not been able to do what I've been doing in this particular situation, unless they were very good at stakeholder management. Yeah, no, I've fortunately, because I came in as the first developer on this project, and have a close relationship with some of the key stakeholders, I've had a lot of latitude to do whatever the hell I like. Yeah, so I think on the delivery side of things, yes, and the stuff I've been doing would have, like, I've not delivered a card in 12 months. So,
You what, sorry?
I've not delivered a card in 12 months. So, yeah.
But do you mean you have like two parts of the team, one part of the team who refactors and changes the code, and one that keeps pushing new features?
Yeah, that's essentially what's happened, is that, and that's kind of what I tried to encourage when the project first was founded, was to have like a core tech team who wasn't delivery focused. They were just there to ensure that the quality of the app, and through the vagaries of organizational reorganization and agile and everything, things got messed with. But now, actually, there is now a core platform team again. So I don't know if they're tasked with cards to deliver. I couldn't say. I'm not actually part of that team anymore. Yeah, I was in a bit of a special location. But if you're a serious sort of tech lead who has inherited a code base like this, you have to make a very strong case that this sort of stuff is necessary. And it has to align with the business desire. Now, the business wanted a more modular application. Like, they wanted to be able to do things, more feature delivery, more feature teams and so on, and go and, you know, sort of plug in stuff to the app. The app was not in a position to be pluggable, but some of this work helps get to there, and I was able to sell it in that way, and that this is increasing the modularity of the application. It makes it more, it adds potential. As I said before, we were able to bootstrap and build a whole replacement sort of subsystem in a separate library, in a separate framework, because kind of this work had been begun and started. If it hadn't been begun, that would have been a lot harder. Would have had to if-def everything out or something, which would have been horrible. For me, it created pull request hell for me. Yeah, so one of the other side notes is I only work at this particular organisation 2 days a week, so I have to do all this very slowly. And so you have thousands of commits creep up and behind you. And so it just makes, yeah, a bit of a problem of rebasing and getting everything to merge and stuff. I'm not sure if it created more pain on the other side, Michael. Right, yeah. Yeah, no, yeah, it's pretty impossible to review several thousand file pull requests. Flask tries. He's very diligent. He spotted a bunch of my fuck-ups. So, yeah, it's good to have people like Vlasta who've got like laser-like focus on that sort of thing. Yeah, there's a number of strategies. Had I more time and more, maybe more resources applicable to this, I probably would have done it on a slightly more piecemeal basis, sort of establish certain steps and stuff, yeah. So there's definitely mistakes I made or compromises I made about how to work and do this work, which you are no doubt aware of, that caused maybe a bit of frustration here and there. But, yeah.
So how is it dealing with existing developers on the projects and the changes you will bring about this?
Existing developers on the project.
Yeah.
So, well, when the project kind of kicked off, there were no existing developers. So it was a new project with new developers. A few people who had worked on the code previously were brought over, but it was only 2 or 3 of those. But the main, I think if you mean more the other developers working on the project at the time, yeah, I mean, I informed them of what I was trying to do, and yeah, mostly the pain was on my end, I think. Because most people, once a new framework arrives, they're like, oh, all my code has moved into this framework now. I will work in there, or whatever they're having to touch for the particular feature. It was more of a problem of like catching up with people's changes. Like if a code that wasn't in the frameworks already, if people were changing them. And the vast majority of changes I was making actually were just moving files. And fortunately, if you don't change too much in the file, gets pretty good at recognizing a file change, even though technically it doesn't track file moves. So its heuristics for detecting file moves and things actually are good. So even if people had made quite radical changes to a file, if I hadn't touched those lines, but I'd moved the file to a different location, it didn't really cause a merge conflict. I mean, it might have minor ones, and project files are a bit of a pain, but in general, changes that were happening. And also, as the final graph kind of noted, most of the people were busy off writing Swift code. You don't create another 50,000 lines of Swift code by maintaining the existing 100, 200,000 lines of Objective-C. Everyone was like, oh, Swift, excellent, and doing their thing. And I was mostly moving around all the old Objective-C. So yeah. So I'm hoping it didn't cause too much consternation on other team members.
I've got one question. I've recently deplotted a project, got to move a lot of things around. But I guess just to put all this change in perspective, are you running on iOS,
Yeah, we do. So the project still uses CocoaPods to manage the external dependencies, and that works fine. It starts getting, your pod file starts getting a bit complicated when you've got all these extra targets. You're having to import things, and some of the legacy code exported the pods in the headers, so it's a big no-no. If you've got a framework and it's using a type from a pod, say Lottie, take Lottie for example. So you've got some animation and you want to make an animation view and you subclass Lottie animation view. You have to then import that Lottie framework in your header, and then you want to expose that view and out of your UI kit or something into the rest of the app. What you've effectively done is expose your private implementation detail of using Lottie in your UI kit to the rest of your app. And that causes a bit of a problem with CocoaPods. CocoaPods complains about, well, when Xcode builds the frameworks that don't use Lottie internally themselves, they're all like, where's Lottie? I can't build this module. What's module Lottie? And so you then have to say in your CocoaPod, well, actually the dependency of this target is also Lottie and stuff. You've got to bring that into the header search path for that particular framework target, which is a bit of a problem. Ideally, you don't do that. So if you've got implementation detail like your dependencies on your CocoaPods and stuff, keep it private in your framework. What was this you were saying?
I was just wondering.
Oh, the targets and stuff. It's an iOS 10 and 11 app, and it's iPhone and iPad, and what else? That was it. Yeah.
Was there one more question?
Okay. Oh, we got another one.
When you decide to drop iOS 9?
When dropping iOS 9, day one.
Do you have to make a business case for dropping it?
Not really.
Jesse could probably answer that one, because he just has to go through that process himself.
No, 9 was easy.
Yeah. No, we didn't have to justify that. Again, I was in a kind of fortunate position of having a reasonable amount of influence.
So you spent a year to build this beautiful architecture, right?
Yeah.
And the application was started in 2012, right? So 6 years ago.
Yep.
How do you make sure that in 6 years you're not in the same situation as 1 year ago?
I can't. Like it's up to the development team to see the value in what's happened, and if they don't see the value, they'll get back into the same mess they were before. I can only influence a software project when I'm working on it, and by trying to instill a culture or instill practices that people continue after. You know, as a consultant, you're in that kind of situation. I mean, even if you're a permanent employee of an organisation, if you then subsequently decide to leave, anything that happens after you is not really your problem. I mean, hopefully people have learned or have got something out of a value of what you've done and continue to practice those things. But that's the other thing is, like, things change, right? Like practices change. Bob will talk about like Swift Package Manager. Maybe in 12 months' time, we're all using Swift PM to do manage our dependencies, or maybe, you know, it'll help us build frameworks or whatever. I don't know. It's
Best case scenario, in 6 years' time, you get to come back.
yeah. Maybe. I'm not out of there yet. So yeah.
Awesome. Any more questions for Oliver?
With that non-code, like doc comments or just like normal server documentation, did you have policies about, you know, if an API has to
Actually, the practices of the team at the time were pretty good with documentation, so didn't really need to go too far in that direction. We did institute things like SwiftLint and other tools like that to try and keep sort of an eye on people's practices within the Swift code. And we looked at using Objective-C linting tools and stuff as well to sort of measure code quality and what have you, but you either have to pay for expensive commercial licenses for things like SonarQube or deal with flaky open source solutions. Yeah, so there hasn't, one of the practices I did try and introduce, hopefully successfully, is the process of architecture decision records. And I might do a lightning talk at some point about those things. Yeah, documentation and stuff, that's a challenge. But it's not too bad in that particular Codebase.